How'd you like that take coming in? How
Mhm.
you doing? It's Monday night, and it is the Physicist and Philosopher Hour. The physicist is Dr. Claudia Albers. Hello, Claudia.
Hello.
How you doing?
I'm
And
very well, thank you. And you?
good. Doing good, doing good. I'm sure y'all know who I am. So
Yeah, you're the philosopher.
the philosopher. Yes, yes. You know, someone asked me one time, what qualifies a person to be a philosopher? And the best thing that I could tell them is being able to remain flexible as a reed, even as you become an oak.
Hmm, very interesting.
How's that?
Yeah, I always thought that a philosopher was basically somebody who thinks about all the abstract things to do with life.
True that. And it does take you down a most interesting journey. I mean, so your journey to become a physicist was what pushed you or what led you into that?
Well, I decided I was going to study physics when I was 6 years old because my mom had bought me a book on astronomy and I loved it. And it said there that if you wanted to study astronomy, you had to study physics and mathematics at university. So I decided then that's what I was going to do.
Most kids at 6 years old, Claudia, are, realizing that it's a make-believe world. And yeah, I mean, they're not saying, well, my life path is going to be, I think that's remarkable. I think it's great. So at 6 years
Yeah.
old, you had figured out that that is a unique awareness of spatial awareness
Mm-hmm.
from
Yeah,
a philosopher.
I was maybe a little advanced. I actually remember things from the time I was 6 months old, or maybe even younger, because I had no language. I remember what it was like to listen to my mother talking, and all I could understand was the feelings in her voice. I couldn't understand the words, but I understood she was surprised.
Hmm. Have you ever
You know,
done any regression therapy?
no, I
Okay.
just remember just like that.
Well, I know a number of other scientists who would love to talk to you. Hey, Brenda Fisher, haven't seen you in a while. How you doing? Jake, hello, everyone in the room. Michael, Aaron, good to see y'all. Red, good to see you. Fabo, hello. Crazy Squirrel, Squirrel Crazy. I love that. How you doing? Well, that's interesting. You actually should look into that.
Yeah, well, I
There,
mean, I've always found how the brain works very interesting,
well,
and
because the
how it's
debate.
put together, and how learning happens, how thinking. I was always very interested in that. I always analyzed my own thinking from the time I was a child.
Well, I look at this from a perspective of so the great philosophers of our age, going all the way back to Plato, Hermes, um, and beyond that, you could even go into Thoth if you wanted to say.
Mhm.
But here's the point. So to say that you are aware in the womb really brings out the question then what point does soul enter in? Because the debate has always been: is man spirit? Is man soul?
Mhm.
Is man body? Yeah.
Yeah. Well, I think it's quite clear that the moment that you have your genetic code, that your soul is in there, you that human being, even though there's a lot of multiplication of the cells that will still occur. That's the way I see it. I mean,
Well, Hermes says that there are those that are in charge of matching the spirit to the soul.
mhm.
So
Yeah.
yeah, I mean, and it's amazing how you look at the Hermetic principles, the seven laws particularly, and how they so They explain science. They explain religion. They explain really why we're here.
Mm-hmm.
You know, I contend that this is a training ground. Hello, Laura. Good to see you. Sherry, good to see you. I'm just saying hello to everyone. The room's filling up quick.
Hello.
So this is very interesting, Claudia. We should talk about this in the aspect because, you know, there are those I've had guests on who would be very interested in that aspect of having remembrance of your mother speaking to you. That's pretty cool.
Mm. Yeah.
It really is.
Yeah, I have memories of certain things that happened when I was a little baby. So I don't know why, but it's just the way it was.
Well, you have more of the Hermeticist in you than what you may realize.
Yeah, I've always analyzed my own thinking, like I said, from the time I was a child. Now, when I was 9, when was it? When I was 11, I think that's when I came I went to South Africa. I couldn't speak English. I just knew a few words. And I decided for myself that the way I was going to learn to speak English was by thinking in English, even though I only knew a few words.
Now that's interesting. I contend that there is a part of the brain to those people who are bilingual, trilingual, etc., that have the ability to be fluent in other languages. There is a certain spatial aspect of, I think, seeing reality, because you have to, just like you said, you had to begin to think English, even though you knew a couple of words.
I only knew a couple of words. That meant that, you know, if I wanted to think to myself, okay, I need to go to the bathroom now, I had to search my brain for the right words in order to have that thought in English.
Interesting. You see where I'm coming from? That's a very, it's unique for me as a philosopher, because what it tells me that self, which is, I contend, is spirit, that you had the ability to discipline the mind, the soul, into being at command of the spirit mind. And when yeah, I mean, seriously.
I sometimes am surprised how much wisdom I had as a child.
Stars, you know, there would be others who could contend you were probably a star child and probably still are.
I don't know about that, but I had a lot of wisdom.
Well, all things are possible.
I'm surprised sometimes that I did, because as an adult, you know, you become more wary of life. Whilst as a child, you're more adventurous. You go and experiment with things that you may not as an adult. And yet, you know, I would realize certain things and do certain things which I probably wouldn't think of nowadays, you know?
Yes, but on the other hand, you also, though, today as an adult, take a different kind of risk.
Yeah.
Yeah, I mean, you know, when you begin to challenge the status quo of any given field, discipline, etc., that, I would say, is no different than as a child when I was thinking of standing on the 10-meter platform and jumping off of it. Yeah, because once you jump off, there's no stopping until you hit the water.
Yeah, I was very adventurous. I used to climb up onto roofs and jump from one building to the next.
Ah.
And one day I fell off the roof and I hit the side of the building. And I slid all the way down to the ground.
Wow.
Yeah. I must have been, what, 9 years, 8 or 9 then.
No broken bones?
No, it's just a bloody mouth. Blood all over my mouth because I hit my mouth against the wall. I couldn't eat anything for days. I had to drink through a straw.
Wow. Did that curtail the compor?
No. I was doing it with a friend of mine. And after I was better, a couple of days later, she said, maybe we shouldn't do that again. I said, why? Let's go do it now.
Interesting. So, folks,
Crazy.
No, actually, I think what we're getting, I think this is great, Claudia. We're getting, the more of the person, and it helps put things in perspective. I think that's very interesting. I'll have to keep that in. It doesn't surprise me now that where I begin to see how you see things in your writings and the science and how your mind sees things. That is what I love about this experience. There's this.
The other day I was thinking of, there was one class I went to. It was a science class. I didn't go to many because I kept moving from one system to the next. But I went to one of these first classes, and it was in Portuguese school, still in Portugal. I was going to a Portuguese school in Portugal at the time. And I think I must have been about 11 then, just before I went to South Africa. And the teacher was showing me, she would show a glass of water, and we had to write down what we observe if we tilt the glass.
Mm-hmm.
And I just couldn't see what was going on. So she came to me and she tilted the glass. She asked me, what do you see? What do you see? And I couldn't figure it out, what she meant. She said, don't you see that the level of the water is always horizontal no matter how you turn the glass? And it was like this light bulb went on. It was like at that moment, I learned to observe.
Interesting.
And it took one lesson where I had failed. And from then on, I realized what observation was about. You have to really notice things.
Mm-hmm. Yeah.
So it was things like that got imprinted in my mind.
Dr. Robert Lanza, in his book Biocentrism, focuses in on that. In fact, on my whiteboard, I have what he wrote about time, which is interesting. And it says time is a concept looking for a function.
Interesting. I think of time as a way. Actually, time is a very abstract concept. You can only tell that time is passing when things change.
Yes.
And what changes is energy. Energy is transferred. So time is a function of energy transfer.
His contention is that time is only observable when there's an observer.
True.
And he gets very detailed in this, and he explains mathematically how that awareness, reality, we see photons. So his contention is, for instance, I can see behind you a door frame. Now you're looking at the camera and you're seeing my back wall.
Mm-hmm.
So here is his point. As an observer,
but in a way, I mean, if there was no one to observe time,
does time exist?
No, I mean, it would still exist, but it wouldn't matter.
Well, now that's semantics on a word.
I
Talks extensively on that.
Yeah, you have to look at a clock to see that time is actually passing.
Well, as he pointed out, each event is an immersion in a movement of time. And that you and I, all of us, we exist as static. We basically insert ourselves into this thing called time. And we only observe it as long as we are actually observing this energy. I mean, it's like someone who...
Yeah.
Yeah. Well, think about our great-great-grandparents. So let's go back to, let's say, late 1800s. You and I could read about what their time was like, but they would be the only one who could observe that moment of time.
Mm.
You see what I'm saying?
Yes.
Yeah. And that's what I love about your theories when I read that, because people so, Claudia, they become so rigid in their perception of what reality is.
Yes. The thing is, what I try to do is find out how it all works, how the universe works. My perspective is that there are certain laws that govern it, because I believe
Yes.
that the creator created it. And it's up to us to try and understand what those laws are.
And we do make mistakes along the way.
Oh, yeah, all the time.
We do.
This is
Yeah.
how you learn.
Yes.
But the thing is, even the mistake, you can learn even from your mistakes. But what I want to do is find out the truth. And you have to observe the universe to find out how it really works. You can't just look at your theory and think, oh, my theory is so beautiful. Now I understand how the universe works, and then just keep on working with the theory. No, you have to keep observing the real universe. And so that's why I always say observation has to drive theory, not theory drive theory, which is the way most physicists do nowadays. Is, okay, they think we understand the universe so well. There's hardly anything else to understand. All we have to do is perfect the theory. That's how physics is done nowadays.
Yeah, I totally agree. I think philosophy is much of the same way as religion, as all the different functions of the immersion of this experience. You said, I think one of the key words, what is the real universe? And, you could take a certain point of view and contend that any one of us sitting here right now is truly limited only by what we can observe walking outside and looking up. I mean, in reality, that's the only thing that you and I could say. If you and I were meeting together and we're starting to write a paper together, we would say that this is observable. I have a witness here, and this is what we're seeing. For the most part,
Yeah.
we're seeing satellites, we're seeing simulation of models. And I contend is that, how do I know what I'm really seeing?
Yeah, that's the thing. There is a lot of strings to connect, because not only is there truth in observation, you have to consider the fact that there are those who would like to fool us. So either way, you have to use logical deductions to build up a holistic view of what's going on. And it's complex.
It is.
It's very complex. You have to realize you have to sort out the truth from the lies often.
And that gets complicated.
That gets very complicated, because we're living in a world that's built on lies.
Yeah. And
yeah.
Key deception on that. It really is. As a philosopher, when I go out and I look at this, Claudia, and I think a lot about our conversations, but I also look at, the 7 principles, and I'll send those to you. And I think you'll see the beauty of science in them, is that I only observe light because I've been taught that that is light. I only observe darkness because I have been taught that that's an absence of light, but yet even in the darkness, there is a presence of light. Now, if I had been taught differently in a different, let's just say different language, that would then see that those elements would be different, well, our whole science would be different, would it not?
Well, not necessarily. The way the universe is, you may use a different language to describe it, but the way it works can be understood whatever language you use. You can use mathematics, English, French. The thing is, you're describing the function and structure and mechanisms of a working universe. It doesn't matter what language it is, as far as I know.
You said mathematics, and that is that key on that.
Yeah, mathematics is one of the languages. It's one of the most precise languages. There's some things you cannot do without mathematics, because it's the only way sometimes to get to a certain type of answer which you need. You have to do a calculation. But it's a language. It's a language like English is a language. It's a written language more than a spoken language.
So Claudia, when I was back in the 80s in working with companies like the Post Group, so I'm a big fan of the Star Trek Next Generation, and anyone who watches that, I suddenly seen a flaw that defied the laws of physics. Because in most of the scenes, if you see it where you're in the captain's quarters and he's looking out the window, right? You got the window and you're seeing the flashes of light going by. Well, wait a minute. Where's the light source that is coming from when you're going at warp speed at, multiples of c? You wouldn't see anything.
Yeah, I suppose so.
Well, I mean, where would the light come from?
Yeah, the thing is, what they are doing is actually moving warp speed. They're moving space with them. So within the space around the ship, there is light. So that may be that. It's photons moving with the ship itself that are still in, because there might be a little cushion between the ship.
Well, one would think you are correct. So maybe we had it. And by the way, how that was done, it's called stop motion. And in the studio, we actually had the model of the Enterprise, and it was put on a platform, and we had 16 millimeter film that was shooting this. And actually what people are really seeing is slow motion.
Oh.
That's how you get those light streaks going through.
Okay.
And here's an interesting thing for all you Star Trek Next Generation buffs. So on the 1707 D model, that's the next generation with the saucer and the propulsion sections. So all those little lights you see, those are actually pieces of rice painted with luminous paint.
Oh, really? Oh,
that's how that's done.
goodness.
So you have the camera that's on this mobile swing, and it's taking the pictures of the perspective of the Enterprise, and as it's moving, the camera is doing this effect, and it gives you that effect that you're seeing lights in a model.
Wow, that's so interesting. I always used to love watching Star Trek.
Oh.
Yeah, I used to
see, high five.
Yeah.
See, folks, I'm telling you.
And the thing is, Star Trek, the language that they used was always so scientific, descriptive of scientific concepts.
Yeah.
I used to think it's like this actually exists.
Makes you wonder, doesn't it? So one of the great experiences I had, Claudia, was back in 1999. Yeah. At the Hilton, they had the Star Trek Next Generation experience. And they had spent millions of dollars on this. And you had to pay, but you could actually go in and become on the interactive side of it. You could actually walk on the bridge.
Wow.
Oh yeah, it was
really?
it was very cool.
Oh my goodness.
I have some pictures I'll show you of Universal.
That's amazing.
It is amazing. Hold on one second. At Universal Studios back in the same period, you could actually dress up as your favorite Star Trek character and actually
Wow.
shoot a whole scene. So anyway.
That's amazing.
All right, folks, there you go. You see, this is what, I think we've talked more philosophy than we have talked anything, Claudia.
Yes, that's
I
amazing.
like this. So I have a couple of things before we get to your papers. I wanted to show our audience, Claudia, there are some pretty cool new websites out. I found this one.
I just wanted to mention, Wayne, that Scott started his MFA website, and I'd like to say hello to all the MFA members.
And that website is?
Yeah, he's very excited. He's been writing lots of articles, doing a lot of research, promoting the website. And it's www.mfamediagroup.com.
We ought to have Scott on next week.
People, if are interested, can go and check it out.
Okay. Maybe he'll come on next week.
Maybe, yeah.
Yeah, we'll just feature that.
Mm-hmm.
All right. Well, hello, all you MFA members. Hello, and thank you. Namaste to you. So, Claudia, I found this really cool new website.
Yes, I know about the Climate Reanalyzer. I actually started looking at these maps when they were still run by the university that used to run it. But then they partnered with NOAA, and then they never showed what they used to show before. Never did. And they used to show a great difference in temperature at the poles, which they don't really show anymore.
Yeah, they're showing, let's see, there is some cold air up there. I've seen that.
Yes, I think that once NOAA got involved, they just never showed the same degree of difference between the poles and the rest of the planet. I've noticed that. That's why I haven't looked at them recently. I use my old images rather. I even mentioned that in an article.
And which website would that be?
No, I just use old images from 2016 and 2017 in my articles rather than current ones, because these models are not showing the same degree of differences in temperature between the poles and the rest of the planet that they used to. I mean, I have images where it shows differences of 5-6 degrees between the rest of the planet and the poles. Because they do. You see, they're still interesting. But to actually show what's really going on at the poles, I actually have to use old images.
Okay, well,
but this is what happens. NOAA and NASA are in the business of hiding what's going on. As far they don't want to show how bad things really are.
Yeah, I'm gonna write them and ask them. I wasn't aware that they had. Okay, that's cool. Well,
no, but they're still interesting. You can still find lots of things on them. So I'm glad you're looking at them.
I look at it. I mean,
it's the University of Maine. They started this website, and they did this all by themselves until NOAA started partnering with them, and then that was the end of that.
So are you saying that the data is not actual?
Yeah, they manipulated a little, actually probably a lot, so they don't show quite what they used to show.
Okay, well, we move on. This is taking place right now. Let me get the proper perspective. There we go. Where are we?
Oh, that's a nice elongated orbit there.
Yeah, so this is, what is this? The
meteor shower.
Yep, and this is pretty cool because you can actually go in here, and what I find interesting about this, Claudia, is just a fun little website. You can keep up with everything, is you begin to realize very quickly the retro orbit of some of these masses. And so when we look at these meteorite showers, what we're really seeing here is past collisions of something, right?
Yeah, or not necessary collisions, but perhaps a comet breaking up
Okay.
as it goes for its close approach around the sun, and then it breaks up into a cloud of material which comes back periodically and produces these showers. Of course, remember that I wrote that these comets are actually Planet X system. These are the stellar cores that have come in over the years, probably the smaller ones. And we have so many of them, and some are absolutely huge coming in towards the sun. And we have these ones that probably came in thousands of years ago and produced these clouds of material that then are like meteor showers.
This is
and
a
we
cool
have
website.
the current debris coming in as well, which they don't want us to see because they emit strange colors.
And you can see exactly as I continue. You
Yeah,
can
that's
really,
very interesting.
yeah, it's a very cool little website. And you really see here, Claudia, what you're talking about. I mean, and some of these systems are really moving through very quickly.
Yeah, that's exactly the orbit that I had from my comets, because they come right, some of them go right into the sun's corona. So the perihelion position of the orbit is in the sun's corona, and it's a very elongated orbit.
And I can't help but not look at this and just ask myself, this is a lot of debris.
Yes, it is.
I mean, you know, and you can actually come in here and you can put all of these together. I mean, look at this.
Yeah.
Each one of these, go ahead.
Yeah, you see that these stellar cores produce a lot of debris because they shed their outer layers of material, and then they gain a new atmosphere either from the sun, or they go past the earth. They will take matter from the earth and produce their own coma, but it's like an atmosphere, and they will have a tail and so on. So this has been happening, like I've discovered recently, for thousands of years, that these comets, these objects have been coming in and losing their outer layers of material, drawing material from the sun, drawing material from the planets in the solar system. And then they become a part of the solar system. They keep on going into some orbit. The debris is filling the solar system. There are clouds of debris now filling the solar system. And this is just what they allow us to see of it. But it's basically, look at this.
Look at this. This is all of them combined, Claudia.
Wow. And this is nothing compared to what's actually here, Wayne.
Yeah, look at this. And I just find this so fascinating because there's nothing symmetrical to any of this. And you're going retrograde on top of retrograde, integrated. Look at this.
My goodness.
And when you put this into perspective, you get an idea that something happened here.
Yeah.
Something big happened here.
Something big happens every time a comet comes in and seems to break up. At least they say it breaks up. But what actually happens is the comets, or they say they go into the sun and get destroyed, but they don't. They stay in the sun's corona. The core of the object, which is the core of a planet, or what was once a planet, a moon, or a star, does not get destroyed in the sun's corona. No. It remains either in there, or it goes out again into some orbit. And the material that it sheds as it comes in, or it continues to shed, just fills the inner solar system. That's why the inner solar system is full of dust and cloud and debris. And this debris is continuously coming into the Earth's atmosphere now.
I'm telling you, they ain't telling us the story, Claudia. So
no, they don't.
Anyway,
They tell us the minimum of what, you know, because maybe there's been some research done over the years so that scientists have accepted that this has occurred. So they have to keep on telling us that. But to tell us how many of these objects have come in and how much dust is really inside the inner solar system.
They're lying. They're lying.
Yeah.
By the way, this is a group of people, great group of entrepreneurs working with, I believe, I forget which university they are, but they are now getting more and more accurate. They're putting live people on airplanes with monitors
Oh,
So
good.
they're flying at what most of us all are flying at 35,000 feet, between 30 and 35,000. Folks, the cosmic rays, um, in some cases in Maine, look at this, Claudia. It's just off the
They should
scale.
actually measure it on the ground because, to tell you the truth, it could be that the Earth, I mean, there was evidence that the Earth may actually be emitting cosmic rays.
We saw that article. Yeah, we
Yeah,
covered it here.
yeah.
So I just wanted to show you, and here, weather's changing in the country. For America, we have what we call Tornado Alley, and due to, I think it's actually due to more of the planet shifting, we're seeing these, what was been typically called Tornado Alley here, Claudia, moving east towards you.
Yeah, well, does have to do with something that's changing with the Earth, because as far as I know, tornadoes are actually gravitational vortices created by the smaller of these objects coming into our atmosphere. And they actually start to draw material. What occurs is what I call gravitational diffraction, where the same thing that happens with light. When light goes through a small hole, it's diffracted. That is, it spreads out from that hole as if it's a source.
Okay.
When small sources of gravity come inside a large gravitational field, you get a diffraction effect. So what happens is you create a gravitational vortex, just like what happens when water goes through a small hole. What happens is you create a vortex. That's a gravitational diffraction effect. And
Okay.
the hole acts as if it's a source of gravitational waves. So these objects, that's what a tornado is. It's a gravitational vortex.
I can tell you, having gone through one, there ain't no fun.
Uh-huh.
You certainly get the effect of the gravitational vortex real quick, because
Oh, yes.
it's a frightening and harrowing experience. Although I have to say, going through an earthquake is probably more unsettling. I didn't enjoy that at all. Speaking of earthquakes,
Yes. Yeah, Scott actually told me about this. I think he was the first to put out the information about these earthquakes because he was up at night about 1 a.m. when it happened. And these earthquakes off the coast of Canada
Canada, yeah,
were.
British
And
Columbia.
the thing is, the moment I heard about it, I said, that's really bad because that's a sign that something's happening there. Also, the earthquakes were very shallow. And when earthquakes are very shallow, they're very likely to actually be as a result of these stellar cores approaching the Earth, because they would cause a shift in the ground as the gravitational wave traverses across the ground. And so it's very likely that that's what's happening there. But there haven't been any large earthquakes in this region for a long time.
Not for a long time. Yeah.
So I would say that this may be a sign that a big one's about to occur there. And if it does, it's very likely that it will affect the San Andreas Fault as well.
Not good.
Not good at all. This is not a good sign. But
Not
that's
good.
what I immediately thought, that this is not good.
No, and I have a brother that lives up in the Seattle area. And I keep telling him, let me know what those volcanoes are doing.
Yeah.
If you ever get the chance to travel, it's quite something to really go there. You can actually climb Mount Rainier.
Uh-huh.
Yeah,
Wow.
so I have some boy, the group has gotten larger in here. So Claudia, I have some of your papers pulled up, and I
Okay.
thought
That's
that,
good.
yes,
I
all right.
wonder what you chose this week.
Well, there we go. I'm trying to get it pulled up now. I saw a couple that was quite interesting.
Oh, yes, the one about the hot Jupiter.
Yes, yes.
Yeah.
So, what's up? This is a cool one, folks. So, I love
Yes.
this.
Yeah, so this is a hot Jupiter orbiting a star 500 light years away. So suddenly this story popped up. And there are 4 gas giants orbiting, and one is very close. It's at 0.1 AU from the center of the star. So, and it's 11 times the size of Jupiter. So it's not quite large enough to be a brown dwarf, because brown dwarfs are usually classified from 13 times, and that's in mass. I'm not going how they get to the mass, but it's all based on models, which I don't subscribe to, but that's how it's classified. So I'll stick with that. To me, this is a brown dwarf anyway. It's a stellar core because, first of all, the star is supposed to be quite young, and they say it has a developing protoplanetary disk around it, and so it's a young star. It hasn't developed any rocky planets, but somehow it has 4 gas giants. It doesn't make any sense. And gas giants are it's not possible, according to current theories, for a gas giant to form so close to a star, because the stellar wind will dissipate the gases that have to accumulate to form a gaseous giant.
And this is 11 times bigger than Jupiter.
Yes. So,
hello, darling.
Yeah, it's just not likely. And they do say in the paper that they don't really understand how this is occurring. And then I talk a little bit about another one, another hot Jupiter. And this one was so close. I think it was 0.04 AU from the center of the star. And it had a hot spot that was not even facing the star. And this is characteristic of the stellar cores, exactly the way they work, because the way they do it is they absorb energy from the star, and then they start emitting energy from, because they are core, they are star themselves. So they start emitting energy, they start emitting from one spot on the surface, which is not necessarily facing the star, because it's not reflected heat. It's heat that the star itself is starting to emit from its core, because it's absorbing energy from the sun. So this one was doing that. That's where I started I wrote an article on this some time ago. Yeah, this one was 930 light years away, and the object is called COROT2b. And I did write about that in article 142. So I brought it up again, and my conclusion then as well was that this is a stellar core, a brown dwarf, that has come right up to the star and is absorbing energy from the star, just like the stellar cores from the Planet X system have been doing with our sun for many years.
How big is the sun that this, because it seemed like that would have that would perturbate even the star itself.
Yeah, I think that star is probably larger than our sun, because these objects are at least the same size as Jupiter, probably even larger. And Jupiter is 1/10 the size of our sun.
Yeah.
So this star looks a little larger than that. And as you can see, go back to that image, Wayne. As you can see, we have these objects. Look at the image on the right. This is an SDO image of an object in the sun's corona, obviously very close to the sun. So it's a hot Jupiter. Look at it. It even has stripes. It's a hot Jupiter. But what do we call it? We call them stellar cores or brown dwarfs. That's what these objects are. They are basically dead objects, energy depleted, that come to living stars to absorb energy. So, and it seems that about 1% of all stars have these hot Jupiters orbiting them. That's what they've discovered so far. Probably there are a lot more, because most of them will not be visible. They don't emit any light.
Yeah. Well, even 1%. That's a large number.
Is a lot of stars
that's
that
a
have
lot
hot
of them.
Jupiters around them in our galaxy.
We're still discovering things, Claudia. Like
oh,
you
yes,
said.
we are. But it's interesting. This is like the soft disclosure, that, okay, this is actually what's going on and has been going on. That's why our sun is dying. But, we talk about it in terms of stars far, far away.
Yeah. Yeah.
And again, I always explain that the SDO eclipse season shows that the sun goes dark, that these objects cause the sun or actually draw energy from the sun to such an extent that they cause the sun to go dark. And this is another form of self-disclosure, where they were telling us the truth whilst denying the truth. It's the way these people seem to work. They like to tell us the truth, but cover
All
it up
truth. All
and
truths are
deny
half
it.
lies.
Yeah.
So this is interesting.
Yeah. So then I think I go on to explain how the mechanism in the universe suggests that this is how matter is created, how galaxies form, how they eject material, how stars do not form due to gravitational collapse, but the opposite occurs. What happens is expansion occurs, fissioning of stars occurs. They break up into pieces. So galaxies themselves eject material which condenses into compact objects, which then unfurl arms and become galaxies. And these are for the very bright galaxies, the ones with active nuclei. But even older galaxies like our own are ejecting. Remember, this comes from that image that you sent me about the center of the Milky Way galaxy, where I learned so much from analyzing that image. And it shows that galaxies eject globules of material, which then condenses into star clusters. In other words, they fission into star clusters. And that seems to be how galaxies populate the disk, the arms of the galaxy, through ejecting material like this, which then fissions into separate stars. So it's the opposite of gravitational collapse. And the fact that the sun goes dark means that there are no thermonuclear reactions in the interior. Thermonuclear reactions are supposed to stop gravitational collapse. No thermonuclear reactions, no gravitational collapse. That means that's not how stars form. The opposite is occurring in the universe. And I've written a lot about that, so I put all that into this article.
This picture is really interesting because it just shows to me, look what's happening here. I mean, and this is light years across, if I am correct.
It is, because that's an active galactic nucleus that's ejecting material along probably the minor axis. And so it's a very compact galactic nucleus that's in there, very bright, very young, because the greater the energy, the younger the matter. And you notice active galactic nuclei are only about 100 AU in extent. That's about the size of the solar system. So it's ejecting huge amounts of material. I think this is in radio waves. They usually eject a lot of radio wave emitting material, gases.
Is it coalescing as it gets shot out from the core, the nucleus?
I don't see it doing that here. It just seems to be an ejection of gases.
Okay.
But Holt and Arp showed that what happens is sometimes active galaxies that already have fully formed disks are ejecting globules of compact material. They ejected along, again, the two opposite directions at the same time. And this material, because you observe the galaxies at different stages, then turn into quasars, which are very compact, dense objects. And over the course of time, these turn into galaxies. So they're proto-galaxies.
Yeah, because I'm looking at this. I'd like to get the blow up of this one.
Yeah, it's very, you can see the amount of gas that this galactic nucleus is ejecting. It's unbelievable.
So this is gas. It's not dust, right? It's gas.
Well,
we know what it is?
use the terms interchangeably now and then, because dust is small amounts of molecules that are diffuse, so spread out that can be called gas.
Okay.
So dust, gas in the universe, about the same thing.
So here I
Although
can actually,
dust supposed to be larger, larger amounts of agglomerations of matter, but in the universe, because matter is so dispersed, usually it's about the same thing.
as we're pulling this up now, I expanded it out, Claudia. This is
Yeah.
very interesting. I know you could probably just do a whole class on this one because it looks like, well, obviously there's an intensity.
Yeah, look at that jet coming
Yeah,
out
that's
of it.
exactly what I'm saying. What's going
It's
on with
huge.
that?
It's huge.
Yeah,
And you see, the same thing happens with stars. Stars produce these nebula clouds around them, which are huge compared with the star. Don't forget, the sun is tiny compared with the size of the solar system, which is 100 AU. And this is actually what usually it happens with stars. It happens with galaxies. It happens all the time that young matter ejects material. It expands, it blows up. It's the opposite of gravitational collapse.
Do we have any idea what's really happening here? I mean, this just seems to me to be a world that I don't know if our scientists or if we've even been able to comprehend what's really going on here.
Yeah, you see, this is what Halton Arp studied for years. That's what's in his book, what he details in his book, Seeing Red, is about these matter creation events that occur from these very compact, very bright, high energy objects, which are galactic nuclei or young stars. They eject all these huge amounts of material that glow and emit light. The light comes from the fact that there's energy. Wherever there's energy, then there's light emission.
Well, what I'm looking at is this.
It looks like clouds of gas.
We see this come off our sun.
It looks like, pardon?
I said, you can look at this and we get this same kind of effect coming off of our sun.
Yes, exactly. Yeah. It happens everywhere. The same structure and mechanism is repeated all over the universe, everywhere. This is the mechanism and structure of our universe.
It's amazing.
But, you know, it's been denied by accepted theories because they want to believe in gravitational collapse.
They're still trying to figure that one out. Yeah. Claudia, this was wonderful. All right, I got this one because this one is, when I read this myself, I immediately thought of you.
Good.
Well, no, because, you know, the debate of sun simulators, now we got to add moon simulators.
Yeah, the thing is that, you know, the people would like to deny that there's any sun simulation system, would of course say it's not possible to have a moon simulator. But here we have China saying they're going to put one up. So can you deny anymore that it's impossible? But my take on it is, have the powers that be decided that they can no longer deny that the moon is being simulated in our skies. And look at this. This is during the day, Wayne. A chemtrail plane in front of it, okay? So that telling us exactly that our atmosphere is so full of haze from the chemtrails. It's very difficult to see anything outside our atmosphere. So how are we going to see the moon so clearly? Look at it. It's impossible for us to see the moon like that with our naked eye. And yet we look up and we see all these features on the moon. I mean, this is not just photographic equipment. We see it with our own eyes often. What is this? It looks like it's in the atmosphere. Why? Because it actually is. It's a holographic projection. And this is from one of the boogeyman videos. He actually sent me this picture. It's been very nice to send me lots of pictures. And
thank you, boogeyman.
Yeah.
High five, buddy.
You can see that this is a simulation, a holographic projection gone wrong. Look at it.
We're going to blow this up.
The laser, the green laser behind it, that's producing this.
Wow, isn't this?
I mean, look at that. It's unbelievable. That shows you for a fact that the moon is a holographic projection.
Why, Johnny Ringo, you look like someone just walked over your grave.
Yeah.
This is odd now. So what the hell is this? Is this supposed to be the moon? Is this what we're
It's the
seeing?
moon in the sky. The thing is, he has lots of telescopes and he photographs the moon. He was photographing the moon and he caught it doing this. So it just, the holographic projection malfunctioned, basically. Look at it. It looks like the moon. You can see even it's blue, more blue on one side than on the other. So obviously the laser satellites were out of sync a little there, because the blue and the red is supposed to coincide. So something was going very wrong here. And you can see it's gone wrong. You're not supposed to see that edge, which almost shows that something behind it. You're not supposed to see that.
Well, obviously, this is
It's unbelievable that he actually caught this. I think this is classic.
So getting back to the story, so China is, do they say how they're going to do this?
Well, they did explain it. I read it, but it's so confusing the way they explain it. I don't even see how they're going to get a circular moon out of that. But I think one of the things they are trying to do is trying to give some sort of explanation as to why our skies are so light during the night. And the reason why that's occurring is because the debris from the stellar cores keeps coming into the atmosphere. And there's still a lot of it during the night in the atmosphere. And it's luminescent. It emits light because of the energy absorption process. So nighttime is no longer black skies like we used to have 20, 30 years ago. And you can see this is what occurred in Russia a few months back, July 20th, and the sky went dark. Day turned into night during the middle of the day, but there was this glow in the sky. Why was that glow in the sky? Because our skies, even at night, do not turn completely dark because of all the stellar core matter coming in. This one here is from Argentina in 2011. What happened here was day turned into night suddenly from one moment to the next. And then over the course of a few minutes, light came back to the atmosphere. Now, my argument is if this occurs suddenly, because the sun does not go dark suddenly, not even during the SDO eclipse season, it goes dark in stages. So you wouldn't have sudden darkness falling unless it was actually the artificial simulation system over the region failing, suddenly failed. So, and why did it turn dark? Because the sun wasn't shining. It was only the artificial sky simulation system that was illuminating the atmosphere. This was the middle of the day, and it went dark. And at that time, it went very dark because there's probably not as much stellar core matter coming into the atmosphere as there is now. Now, our skies are getting lighter and lighter because there's more and more coming in. So this was most likely, the sun was dark already, and the sky simulation system was in effect already. And I'm writing an article right now where I'm discussing when did the sun really go dark? Because it seems that they started the chemtrail program in 1997, 1998. And I now believe that the main reason for starting that chemtrail program was for the sky simulation system.
You know, I keep on thinking I need to get my book out, the Hitchhiker's Guide to the Galaxy, because something is screwing up here. I want to talk to the architect. That's all I've got to say. Then I know we got a little time here, because here is, I think, was an interesting article as well.
Yes. There, I mean, Scott and I just went out, we were taking pictures, and there, I saw, first of all, this is hexagonal in shape, but a bit flattened. And you can see the blue light beams coming through it. So that would indicate there's a blue I'm going to write another article about how they're simulating the blue sky, but obviously they're using a lot of blue laser light and holographic projections to get a blue sky, because I don't think the sun is illuminating our atmosphere. It's all artificial now. So how they're producing the blue sky is interesting. So I'm going to still write about that. But here I just analyzed it. And one of the things that you have is a shadow of a chemtrail. You see that chemtrail going through there?
Yeah, I see they're making a pentagram as well.
Yeah, there's a shadow there right next to that street light at the bottom.
Did you see this later on?
This huge chemtrail that goes right diagonally across the image. It's difficult to see here, but in the next image, I blow it up so you can see where, there it is. Can you see there?
Mm-hmm.
That is the shadow of that chemtrail, which you now see to the right.
Oh, I see. It's very interesting.
That's a shadow. Now, how is it possible to have a shadow of a chemtrail on a cloud? Obviously, the chemtrail must be below that cloud. But in order for us to see a shadow on that cloud, it means the light source is below the chemtrail. So that's a light source way down below in the atmosphere. And that shows that the atmosphere is being illuminated from inside, from below. Of course, it may be illuminated from above the chemtrail haze as well, and where they would produce a holographic kind of plate with the encoding to produce whatever images they want to. But
this is really odd, Claudia. I've captured this as still they're making a pentagram over you.
Yes, that's true.
It is true.
Yeah,
it is true.
I didn't even notice that. I was so interested in.
Yeah, no, they're making a pentagram over you. So the question I have on this is the luminosity of these chemtrails are starting to get really weird. Look at this.
Yeah, I mean, those are not chemtrails. Those are actually light beams coming from the sun simulator.
Look at that.
Yeah, so that shows that they're using blue laser light. That's at least one of the laser lights that's intersecting on there. And what I said was it actually changes shape. The light source changes shape, which indicates to me that it's actually a reflection. So it's most likely reflecting off something like this. And this is a picture. I think that this came from a Mr. MBB333 video where someone captured this in the sky amongst the clouds.
Actually, I have a number of places. Keep on talking. I'll see. I know I don't have it on my.
Okay.
But
so
yeah.
This is a hexagonally shaped array of mirrors. All the mirrors are hexagonal as well. And it's amongst the clouds. So it's at cloud altitude. So it's most likely part of the devices that operate from within the atmosphere. And so you would have lasers probably be transmitted and reflected in some way and intersecting on this thing. You see it's got a hole. So light may be coming from the back, reflected back towards the mirrors and then out from the mirrors. So that may be the way this thing works. I'm not sure. Maybe there's another one in front of it working together with it. I'm not sure. They probably...
Claudia, I contend that the videos that we captured in 2015, I believe, from the ISS, this experiment that was going on, you know, they now have the ability to generate off the ISS something that is as bright as our sun.
Yeah, to tell you the truth, I think they've had that ability for a long time, but they keep upgrading. They keep improving in an effort to hide as what's going on as more and more stellar cores come in and start affecting our planet. And this is an image which Scott took a few weeks back. You can see that two white laser beams running through this object. And you can see that it's part of a lensing system, because it's real. No matter how you move the camera, they're still there, but yet they are in front of the background. So this is to do with the imaging system that they are using to produce this object in our, or the source in our atmosphere. It's an image, the product of some kind of lensing or holographic system. Holographic system is a type of lensing system anyway, except that it produces three-dimensional images that look like actual real objects. So that's the difference, but it is a type of lensing system. It must use a photographic plate with some kind of a code on it. It's a diffraction type of code where when light goes through it, it produces a field, a three-dimensional field that looks like the actual object that has been encoded on the plate. So this seems to be what's occurring here, but you can see that these are real rays, but they're in front of the background. So they have to be a type of image that's in the foreground.
Mm-hmm.
And there you see that this I captured some months back in April, where again you could see the shadow of that chemtrail on the clouds above it. So again, showing that there is illumination of the atmosphere from within, from actually quite low altitudes in the atmosphere.
Yep. I have seen this all too often. In fact, you know, they're starting to really begin to spray at night, and it's really odd when you see what's supposed to be, you wouldn't think you would see it at all, but it shines. It shines. This is really interesting, Claudia, what we got going on here.
Yes.
It's yeah, it's a little distracting because it's going on all over the place.
Yes, I think it takes a while to actually accept that just about everything you've been told about this planet and the universe and the solar system are lies.
Yes.
I mean, it's taken me a long time, because when I first saw what was going on with the sun simulation system, it didn't even cross my mind that what we were saying, I knew it was a sun simulator, but I always thought the real sun was behind it. But suddenly I realized, wait a minute, but the sky is not as bright as it used to be. Why? And if the real sun was shining, we would have the sun simulator and the sun. And the moment you see the real sun, which is always perfectly round and yellow, next to the sun simulator, you would know the sun simulator is not real.
Yes.
So I realized that we have sun simulators because there was a need to replace the real sun. With the real sun, plus the real sun would hide the stellar cores in the sun's ground. I mean, they've been there for 5,000 years. What has been hiding them from us is the actual sun's brilliance.
And that's been kind of my contention as well, is that, let me pull this up. So,
yes,
so I think they've been doing these experiments because someone asked me, they said, well, how can you let Claudia sit there and say that there's a sun simulator when we can see the sun? And I said, you think you're seeing the sun.
Yeah, exactly. They think they're seeing the sun because the real sun is not visible. If the real sun was visible, they would know which one is the sun. The real sun looks real. First of all, it's perfectly round. It's always yellow within the atmosphere. The sun simulators are never perfectly round. If you notice that they look hexagonal.
And you can see this, right, Claudia? You can see the screen, right?
Yes.
So
yeah, I like this. I actually want to write an article on this because this is the missing part of my sun simulation system.
I think this is what they're testing, Claudia.
Pardon?
Go ahead. I said, I think this is what they were testing.
Yes.
So go ahead. I cut you off, but yeah.
Yeah, you showed me this before. It's very interesting. And what it is actually a real artificial sun. So it seems to be spherical. It seems to actually have a type of atmosphere, gas, and it seems to be electrical. So it has a high potential on it, which actually ionizes the gas. That's why it looks pink. So this gas actually ionizes and emits pink light. And the object itself, which seems to be spherical, seems to be emitting white light with this pink ionized gas around it. Seems to be fed with lasers, probably from the ionosphere, with energy. You can see the laser there.
Yeah, you can. And look at the spherical object. That's just what gets me, Claudia. It's just
this is the main simulator that's probably powering everything else, the whole sky simulation system. And this is also why sometimes we do see it up in middle of the day. So it's probably in a polar orbit close to the midday position. And it goes around and it's, I think
big.
this is the main simulator.
Yeah, it's just so big. It's beyond comprehension what, Well, I
think it will attract stellar cores as well. So
that's what I was thinking.
Yeah.
Yeah. And in fact, when I was just looking at this, when I was reading your papers, and I have this on, as I sent it to you, I'm asking myself, what if in fact they were interacting with a stellar core?
Yeah, I think it's possible that it actually attracts the stellar cores. They come to it and absorb energy from it.
Yeah. This is big. This is, as I said, I just wanted to pull it up. I know we've seen it before.
This is very interesting. I actually was thinking about this, and I was thinking, I wonder where Wayne showed me this. I need to go back to that because I need to write something on this.
I'll send this to you again if you need it. It's a big file.
I don't know what I did with the other one.
Okay, I'll get this to you. And as you can see, ladies and gentlemen, as this is not speeded up. This was exactly how it was coming off the ISS. Claudia, look at this. I mean, it just becomes very evident that there is something big out there.
Yeah.
Something big. And that's why, it's not that big of a problem for me when I begin to think about where potentially this is leading to. That, they're not giving us the full scoop.
No, they're not. And I reached the conclusion that the images we are getting from the SDO satellite were almost likely 20 to 30 years old. And they probably had military satellites up there observing the sun, because I think they knew this was going to happen from the early 1960s, because they started doing things that probably putting satellites up in orbit. Then they started testing the chemtrails from 1977. So they knew what they were going to do by then. And probably at the SDO satellite was probably a military or a secret space program satellite that was placed in orbit to observe the sun. And that's when they collected all those images. And then in 2011, probably when the sun actually went completely dark, they put out the story about the SDO satellite and this and that. And then they started feeding us these old images, which suggest that the sun is still out there when it's probably not.
Claudia, Liz B. asked, could the sun simulator have the mechanics like the old rear projection TVs? But
that's a cathode ray tube.
No, they're actually the ones that had the rear projection, where you would have the projection screen up here and the image was being shot from, and the image was being displayed across the screen. I'll send you.
Yeah, I know how it works. It's called a cathode ray tube, where they were actually accelerating electrons, and it was being emitted right from the back and accelerated with a potential until it hit the screen. I think they put out all kinds of designs, even from the first one that I used.
Yeah, I think that's good point, because
which worked somehow like that, but I reached the conclusion. Do you know that first design that I used, it had a fatal flaw. One of the mirrors was turned around and I had to turn it back to make it work. And that shows that it's actually propaganda. It's actually, they're giving us the idea that there's a sun simulator there, not necessarily the way that they have designed it. I think most of the design that they have, and they do have objects in the atmosphere, I think they are probably being driven by anti-gravity drives, because they have to move at the speed of 1.4, Mach 1.4. That's 40% faster than the speed of sound. So it's quite fast.
That is fast.
Yeah, so I've calculated that.
Caught some of those little bogies going across.
Yeah, so that's how fast they move. They would stay stationary with respect to the sky projection system, which remains stationary whilst the Earth rotates inside it.
Yeah.
So
it gives you sometimes foundation, Claudia, about the firmament.
Yeah, well,
it does.
It's the sky projection system, which it's artificial. That's what they created to simulate the sky, the whole sky, the daylight sky and the night sky. Because if the sun's not working, the moon will not be illuminated, it will not shine either.
Yeah, and people don't realize all of our space probes, our satellites, or the ISS and whoever the Chinese have up there, it's in our atmosphere. It's only 220 miles up. I mean, and sometimes I question if it's, if it's really 220, 250.
Yeah, the thing is, we don't really know. I mean, there's probably lots of stuff up there, including perhaps something which they use
I'll
to
tell you
take
what,
the
Claudia,
pictures that come off the ISS. But
when I win the lottery, I'll make sure to get Musk or Richard Branson, and we'll get a ride up there.
Yeah, that sounds good. I mean, seeing it with my own eyes would be a good thing. I'd like that,
all right.
Because I cannot believe I just cannot trust whatever
I get it.
we get shown. There are so many lies. It's difficult. I have to really think before I accept, okay, that's it. I mean, they may have some kind of ISS there, but I think whatever they're showing us about the astronauts inside it is actually filmed on the ground,
Well,
they're not showing us what's really going on, if there is anybody up there.
Well, ever since we landed our birds, it's hard to say. Well, Miss Claudia, what a night. We definitely, people said, well, extend it out a little bit. We did. So, so Claudia, do you have anything coming up this week on your channel?
Well, I just keep writing one after the other, trying to figure out what's going on. I'm quite happy that I have sort of figured out how the universe works. That it's the opposite, but you never know everything. There's always more to discover. I'm happy with what I've discovered so far. I'm happy that I've understood sort of how the sky simulation system works. And that sort of thing. I still
and you
get
have
lots.
Your book, right? You have your book?
Oh, yes. And actually, Scott put together another one. Yes, I have my book.
I left the link.
Yes, I'll leave a link. I don't have a copy yet of the new one, but
I have the link, the one you sent last week.
Yes, that one I have here, the Planet X and our solar system. I'm very happy with this one. I think this is one of my best books.
Excellent.
Yeah, I put it together and I worked hard on making it work without making it too long.
The holiday season is coming up. They make great
Yeah.
gifts. And by the way, I've left the link for the hoodies. We have limited edition of the Physicist and Philosopher hoodies. I've ordered mine. They should be coming in here, I think, next week. T-shirts as well. So people, if you want to, there they are. They do make great gifts.
Yes, yes, and it's getting cold, and they're very warm. I actually have some of them, and in winter they're very, very warm. Those hoodies.
See, that's what we're going to talk about, and it'll be cold here because I got a sense that December is going to be a December to remember.
That rhymes. Are you a poet?
I am, and I didn't know it.
That's wonderful.
But I'll show it.
Good.
Because I do know it.
Oh, wow. Poetry.
Yes. Can you see the Steiger rap going on?
Yes.
Claudia, it's always fun, my dear. Always fun. And I just want to thank you, everyone. Listen, the after dinner entertainment was provided free on the house.
Mm-hmm. And it was excellent.
Well, thank you. Thank you. We aim to please here.
Yes.
Well, Claudia, it's just been a delight. I appreciate you so much. I told you before, I think
and I love doing this show with you, Wayne. So.
Well, good. I'm glad. It's a happy time.
It is. I get to talk about all my theories.
Well, and that's what it's about.
Yeah.
I keep on telling people, the doctor said it's theory, folks. Do you know the difference between theory and,
Yeah, it's theory based on observation, which helps us understand the real universe.
As a good friend of mine who is a cop will tell you that when he arrives on an accident scene, he says already they know you can have 4 witnesses that saw the accident. You're going to get 4 different stories of the same perspective.
Mm-hmm.
And in detail,
Yes.
Yeah. So
different people see different things.
They do. And that's why, great free thinkers get along very well.
Yes, indeed.
Well, Claudia, I do appreciate you. I'll see you next Monday. Everyone, thank you again, all the MFAW members coming in. Thank you for your support. Let's get Scott in here and maybe we can get an update on.
Yeah, maybe you can come on next week.
Good. I'd like to do that. That would be great. And everyone, take care of yourselves. Have a great week. Be kind to yourself. You can't be kind to others until you're kind to yourself. How about that?
Yeah, well, the Bible does say you should love your neighbor as yourself.
Yes, and I tell that people.
Includes yourself.
And that's what the problem is, Dr. Albers. Most people don't love themselves.
Yeah,
it's true.
Sad.
All right, everyone, be good. We'll see you next week. Bye-bye, everyone. Hold on, Claudia.